Hi everybody, Patrick here from Engineering Shock Electronics. This is the IR clip assembly and test video. And thanks for pledging towards the IR clip Kickstarter campaign. I'm going to solder this together to show you how to solder the DIY kit together, and then we're going to throw it into our Arduino Uno and have some fun. So you can skip ahead, but this part won't take too long. It's a very easy DIY kit. If you pledge towards a fully assembled unit, this will all be done for you. In any case, we've got a 4-pin header, the IR clip, a 2-pin header, and a jumper. So first things first, let's talk about the 4-pin header. For the 4-pin header, we're going to want this facing the bottom of the board, like this. Get some solder dabbed on the end of your soldering iron and dab it to one pin. Make sure not to burn yourself, make sure not to short anything. Once that's done, you can lean it down on the ground or on the surface, solder the other 4 pins, and clean up the original pins. So I'm going to do that right now, and I'll show you what it looks like when it's done. Great. Nice solder joints, 90-degree angle. Now it's ready to fit into your Arduino Uno. However, we still have the 2-pin header, and that goes on facing up. So we can add a jumper to it once we've programmed in our IR codes. Now the easiest way to do this is to come at it from this side. Use your fingernail to hold it in place, like this. Turn it around. Don't burn yourself. Add a little bit of solder to your soldering iron and just dab a little bit on this upper pin. Once you're sure that it's on there, it doesn't have to be a nice solder joint because we're going to clean it up. Put it down, solder the other pin nicely, and then clean up the original pin. Done. So now hold your jumper, don't put it on yet. The jumper goes on the top once we've had our infrared code programmed. So this is a different IR receiver than the originally planned. The original planned IR receiver was a VS1838B, and it's okay. This is far superior. I get better distance and I get much better accuracy. So let's go plug this into Arduino Uno and look over some code samples, and we'll talk about how to plug it in and how to operate them, and then you can go through the commented code samples yourself and see how they work and how you can manipulate them. So my Uno is modified a little bit. That doesn't matter. We're going to be using these 4 pins, GPIOs 4, 5, 6, and 7. And we're going to place the IR clip in like this so that the left goes in 4 and the right goes in 7. 4, 5, 6, and 7. 2 of those pins are going to act as power and ground. We're going to set the power pin, the 5-volt pin. We're going to set the relative GPIO. They're all labeled on the bottom underneath here as the power pin. And we're going to set the ground GPIO pin to low, just as an output, and set it to low for a ground pin. And because the IR receiver takes very little power, we can do this. We can actually use an IO pin has 5 volts to power it, and 1 is ground. So the other one is the jumper. I'll look at the bottom of the board in a second. The code samples are all ready for you. So the jumper acts as basically there's a 10K pull-up resistor, and when there's no shorting of the 2-pin header here, the unit is going to say, okay, with this piece of code, I'm waiting for a new set of IR. And so what I've done is I've programmed the program to require 3 sequential streams that equal each other. So if I press on my remote control 1, 1, and 2, it'll instruct me to do it again because it was not received. So I'm ready to upload my code. We're going to upload the first piece of code, which is called IR test. We're going to look through 3 pieces of code here and how they work, because this is a setup video. Looking through the code and manipulating it is obviously your domain. So first things first, I'm going to upload the IR test, and I'm going to show you I'm going to show you what happens on the screen. Before I do that, you look on the bottom of the board and you see IR, 5 volts, GD, and PG. IR is the infrared stream, which is the output of the IR clip, which is connected to GPIO 7. 5 volt. The 5-volt pin is connected to GPIO 6. We set GPIO 6 as an output set to high. The 3rd pin, GPIO 5, is ground to GD, and that is set as an output set to low. And PG is the program jumper. So if the jumper is not added, there's no short across the 2 pins, that pin will see 5 volts. Once shorted, it will see 0 volts, ground. So when it is shorted, it realizes, okay, I'm going to use the infrared stream we have to save to EEPROM memory. So start with the jumper removed, and let's upload the software and look at our serial monitor. Okay, so I've got my Arduino Uno plugged in. Before I do anything funny, I'm going to upload it, but before I even do that, code's commented, you can go through it. What this program does is it allows for you to program in a new IR stream for 10 buttons, 0 through 9, and the power button. We'll go through it. I've got a generic TV remote with me. Not all work, but most do. You want to have a remote control that has the buttons 0 through 9 and a power button for this. You don't have to use those buttons, but you want to have enough buttons that you can work with this. So you can manipulate the code as you see fit. So I've got my IR clip plugged in. I'm going to make sure that I've got it set to Arduino Uno COM4. I'm going to upload it. And once it's uploaded, with the jumper off, I'm going to open the serial monitor. Okay, so let's open it up. I guess I've got a serial monitor already open. Let's just reopen it, and that'll cause a reset, which is what we want. Okay, so all these numbers are an IR dump. They represent the numbers that we need set, we're going to program over in EEPROM memory. And at the bottom it says, getting new IR. Press the same button sequentially 3 times and follow my instructions. So I'm going to press 0. I'm going to press 0 again and again. IR stream is saved successfully, saved to 0. And I'm going to press button 1, 3 times, 2, 3. If I enter in 2 different buttons, I have to do 4 again. Save to button 4, button 5, 6, 7, 8, 9, and lastly the power button. So now that's been saved to EEPROM memory. Now here's what I've done. To make sure that I could use as little space as possible in EEPROM memory, each IR stream takes 5 address bytes in EEPROM memory. So 0, 1. Let's just say the first one goes to 0, 1, 2, 3, 4, and 5. You've got 255 bytes of available memory, so 255 slots from 0 to 254. And I'm only using 5 times 10. I'm using 50 of them. And so as you see these numbers, these are massive numbers. For instance, the last one on the screen, it's in the billions. Thousands. Yeah, we got it. And so what I've done is I've created a way to break this number down into 5 different bytes. How many 10 millions? How many 100,000s? And I basically subtract those numbers until there's not a certain amount left. And so there's a breakdown piece of code that shows you how I've broken this down and how I can rebuild it if I want to. And so what I do is I save these values into EEPROM memory, and then I can reconstruct it later. So I can say, once I load it on power up and I go back to the top, these values are basically the number broken down in the remainder. So how many 10 millions, how many 100,000s, how many 1,000s, and I can basically break that number down into 5 different bytes and reconstruct it. There are different ways of doing this. Some people might think this is pretty rinky-dink, but it's not easy to break down one of these huge numbers into EEPROM memory easily. And so I'm quite proud of how this works. And at the same time, the new infrared receiver's badass. Love it. Just love it. Good distance, great accuracy. In any case, now it's saying I need to change the dip switch selection. Now, dip switch, you can use a dip switch if you don't want to use the program pin. I'm using a program pin, which comes on the IR clip. So now I'm going to add the jumper, and I'm going to press the reset button on the Arduino Uno. And what should happen is we'll see a new IR dump with our new numbers, and you won't see anything at the bottom. So I'm going to press an unknown button. I'm going to press the menu button. Unknown button selected. Now you can program it out, whereas if you get a button that's not recognized, you don't need to have that printed to the screen. You can have nothing happen. But I've added this in. You modify the program as you see fit. So what I can do now is if I press button 8, there it is. It's remembered. If I power the unit off and power it back on, what I'll do is I will actually remove power, plug it back in, and I don't think the serial monitor will respond. I'll probably have to reset it again. Yeah. So I'll reset. I'll open the serial monitor again and get the IR dump. and I'll press button 8 again. There we go. It's remembered because it's in memory. So modify the code as you see fit. Make instructions occur based on execute instructions based on what button is pressed. The next code I'm going to show you is the infrared combination lock. And lastly, after that is we're going to plug the IR clip in a little area, in a different area, and on the analog pins. I'll show you how to do that. And we'll actually try to get a representation of the IR stream on our serial plotter. Okay, so now I've got the IR combo lock code loaded, and what you have here is in the beginning, in the header, I've got a list here, an integer called combo code, and the list is 4543. Any other code will not unlock the door. Now I've got unlocking the door in quotations. Basically, you program it how you want this combination lock to work, or what do you want it to do. I provide the basics. So if you want to get creative, you can program in your own combo code on the fly, but I've got a fixed combo code here of 4543 to succeed in executing a piece of program that's dedicated to this. As you can see below that, incoming combo code. So I'm going to save 4 new numbers and then compare it against combo code in this code. And if they match, then it will say door open. If I get an incorrect number, we'll get something different. So let's open the serial monitor. There we go, we get a reset. We'll get the IR dump. Enter in a 4-digit code, 5555. Security breach, incorrect combination. Enter in a 4-digit code for the 4543. Success, door open. And then you can have this do whatever you want as you see fit. I've got it just to freeze, but in the code down below, there we go, it resets after a certain amount of time. I press button 5. So after a while it does reset. So look through the code, manipulate it as you see fit. It makes for a fun project, especially if you connect this to a relay and a mag lock. You can easily turn this into a magnetic door lock using an infrared remote control. So now that was very easy. It uses a lot of the same code as the previous code sample, and yeah. So now let's look at a very simple piece of code that allows for us to view the representation of our IR code on the serial monitor. So don't worry too much. I've got my I had to modify my my board for one reason or another at one point, and so I've got the IR pin connected to A0, and I've got the jumper connected to A3. We're not using that. We're using pins A1 and A2. We're setting them as digital outputs, and we're using those to power and act as ground. So yeah, the most important one is A0. You can manipulate the code to see fit if you don't want to use these specific pins, and you could turn it around and use A5 as the infrared stream sampling pin. You just have to change the digital pins around. You need to set the 5-volt, whatever analog pin is connected to the 5-volt pin of the IR clip. You need to set that as an output and set it high to power it. Whatever pin is connected to the ground pin of the clip needs to be set as a digital output and set low as a ground. And we're not using the jumper for this one. Jumper doesn't matter. We're just going to take a quick look at the IR stream, and we're going to repeat it on the serial plotter. So this piece of code is actually really simple. We're basically going to create this huge list of 700 pieces of data, and it takes a lot of the Arduino memory. I tried not to set it too much higher than that, but what it does is it was enough to take samples of the incoming IR stream, and we can save it. And that's EEPROM memory, but we can save it locally, and then we can print it to the serial monitor. So it's an easy piece of code. It's commented. You should be able to follow through it, and it's only about 20 lines of code, maybe less. So now that we've got it plugged in, let's run the program and look at our serial monitor. While I haven't commented this code yet, I will. It's fairly easy to work with. We've got a list of 700 that's not used. We're going to set things up. We're going to use A2 as our ground pin, set it as an output low. A1 is our power pin, 5 volts, set it as an output, set it high. Wait 1 second. And then we're going to continuously sample the IR pin on which is connected to the A0 pin on analog pin 2 or analog pin 0. If it equals less than 200, now what this means is when the IR receiver output is, when the infrared receiver is not receiving anything, the output is high. It's 5 volts. And it gets pulled low when it receives an IR stream. And so we're going to see that in a minute. So if it's lower than 200, 5 volts would be about 1023. So 200 is just a number that's less than 1023, which is the full scale voltage of 5 volts. Let's just say if it's less than 200 volts, 200, which is about a volt, don't do anything. So once it receives a trigger, it's pulled low to 0 volts. Then start the next sequence. And here we've got 4 loops. They do this 700 times. Take a sample of the IR line and place it into the list pointed to by the value in I. And I gets incremented every single time this for loop loops. So it starts at 0, and every time this loops, it increments to 1, 2, 3, 4, 5, 6, 7, 8 until it hits 700. Once it's done, that list of 700 is full of different numbers in the area of zeros and 1023s, zeros and ones. And then what it is, another for loop, is it does the same thing, sets up another similar loop to 700, and it prints the values to the serial monitor, the analog value that we have saved to that list over and over again to the serial monitor. But we're going to open up our serial plotter. So I'm going to upload this. Oh, I need to have it plugged in first. That's probably a good idea. Oh, I caught it. Nice. All right, so now I'm going to open my serial monitor. There we go. And nothing's going to happen. I'll just print a... actually, you know what? I don't want to open my serial monitor. I want to open my serial plotter. And I'll press a button. I'm going to press the 1 button. There we go. And that's the representation of our infrared stream. The thin lines are... I think they're considered zeros, and the thick lines are considered ones. So that's how the code basically determines which one's which. There's a start bit, which is actually much thicker, right there. That first bit, very thick, and that's the start bit, I think. And then of course we get durations of I shouldn't call them thickness, but longer durations between when pulled low. And we've got, so basically look at these values as zeros and ones. And if you actually take the code and you break it down and you see, I want to see the hexadecimal value of these IR streams and not get the raw value, which is in the billions. You can basically break those down and actually see that, yeah, okay, so this would equal a certain amount in hex that would match the number. I know that gets a bit more complicated. It's not really necessary. There's so much to know about infrared technology or infrared remote control. There's so many different protocols. And there's a whole other, there's like a course on it. There's so much to know. I certainly don't know all of it, but I know how to make infrared work for me. And after this video, you should be able to use it for your own home applications too, without having to spend hours and hours understanding protocols and how everything works. This campaign does everything you need right for you. So if I press say 5, there we go. We'll see another. So what happens is it doesn't do anything until after the IR stream has been sampled. Now you think 700, this isn't 700 lines. We're getting samples like, we're getting like 10 samples here and like 10 samples here, 10 samples here, 10 samples here, like 40 samples here. I don't know what it is, you know, I haven't broken down the math, but it's sampling every... It's sampling every about 100 microseconds. It takes about 100 microseconds for an analog read to occur. Digital reading and digital writing is much faster. I think it's in the area of 7 microseconds, but an analog read takes about 100 microseconds. And these infrared streams are coming in so fast that we were able to capture everything we need by sampling every 100 microseconds or so. We do that 700 times. So thanks for watching. All of these code samples are available to you if you pledge towards the Kickstarter campaign. I'll be shipping out all the IR clips next week. I'm just waiting on some jumpers. And I've done all the soldering for the assembled units.
and I've got a little bit of kitting to do, but as you can imagine, it's not going to take me very long. As soon as I have this video uploaded and the project page made, I'm going to order the jumpers from DigiKey. They'll arrive in a couple days, hopefully one day, but we'll see either way. It's not going to take me long to pack up these rewards. But without further ado, let me just show you the soldered IR clips. They're in a pile, and I'll just show them to you just so that makes you feel a little happy.
It's a mess. I'll make sure that when I ship them, it's a bit nicer. But at the same time, these are for my test pile. So those are the assembled ones. So I'm ready to ship. Thanks again, guys. I realize this is my second thank you, and thanks again, but thanks again.